guys, it is your second section of Chapter 7, and you now know how to find the greatest common factor. And today we're going to use that skill to help you factor using the distributive property. So it's our first little glimpse at what factoring is, so it's pretty exciting. So what you're going to do is I'm going to have you guys try these two examples completely on your own. You guys know how to distribute something. Distribute a monomial into a polynomial. That's what we did in our last chapter. So you guys are going to go ahead and try these, and then check your answers when you come back. All right, how'd you do? You guys should have gotten this as your answer for number 1. Remember, when you're multiplying a to the third times a, you're going to add those exponents. Same thing here. And then for number 2, same thing, you're going to add those exponents. So I have a feeling if you did make mistakes, it's going to be with your positives and negatives. So be careful with that. And then make sure you add those exponents, okay? So that's just a complete review. And guess what we're going to do today? We're going to do the distributive property, but we're going to do it in reverse. We're going to go backwards, okay? So let's take a look at our steps, and then we'll get into some examples of how you're going to factor backwards. So you are going to determine the GCF of each term that you see, and that's why we did that yesterday. When you found the GCF, you didn't do much with it yesterday, but today you're going to factor that out so you can distribute backwards, okay? So let's go ahead and start with that, and we'll work our way through our steps. So for example number 1, what you're going to look at is each term. So we've got 8a to the 5th and negative 16a to the 4th. Looking at those two terms, hopefully once you get pretty good at this, you guys are going to be able to just kind of look at it and think, yep, I know the GCF. If you don't know, then you can use the long method and factor, do your factor pairs. So for 8, our factors are 1 and 8, 2 and 4, and that's it, okay? And then for 16, remember it's 1 and 16, 2 and 8. Oh, right away I see a greatest common factor. So 8 is going to be the number that you're going to factor out. So I'm going to write that over here. Okay, but you also have those variables, those pesky little variables. So what you're going to do is figure out what's the GCF of a to the 5th and a to the 4th. So remember, you always take the smallest exponent that you see. It's kind of the opposite of what you'd think for greatest common factor. So our greatest common factor, or the amount of a's that they have in common, would be a to the 4th. Okay? So what you're going to do for each of these problems is first find that GCF. Okay? So once you've found that GCF, now we're going to distribute backwards. So we're going to draw our parentheses, and you're going to divide the GCF from each term, okay? So what you're going to do is you're going to divide 8 divided by 8. What does that give you, 8 divided by 8? Well, the answer is 1, okay? But you also have to divide it from this a to the 5th. So if I take a to the 4th out of a to the 5th, how many do I have left? Question, think about it. 1, right? So I have a to the 1st left over. Then we're going to do the same thing with our next term. So we're going to put that minus, okay? And then we're going to do 16 divided by 8, and that would be 2. And if I take a to the 4th out of a to the 4th, I don't have anything left. So I'm not going to write any variable at all, okay? So what I did was I factored out each of the terms, the GCF from each of the terms. So if you wanted to double check, which I think is a great idea, you can distribute normally and see if it works out. 8 times 1 is 8. a to the 4th times a is a to the 5th. Got it, okay? 8 times negative 2 is negative 16. A to the 4th times nothing is a to the 4th, okay? So you can go the other way. So I'm going to put up here, distribute like normal to check. You don't give a crap about your grade, you don't need to check. But if you do care, I think it would be a really good idea, okay? So that's it, really. You're just distributing backwards. So your final answer should have the GCF on the outside, and then everything that's left over from each of your terms should be on the inside of the parentheses, okay? Leftover plus leftover, and it could go on for however many you have left, how many terms you have. Leftover, oops, plus blah, 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 okay? So I always think of my mom's meatloaf, you know, put your leftovers in there. Mom, meatloaf. Okay, so let's move on to number 2. So we have 6n squared minus n, 9 to the nth. So now we're going to find that GCF. So hopefully this would be one where you could just see the GCF is, think about it, 3. Okay, this is 6 and 9. I can automatically see that the number they have in common is 3. If you don't remember, go ahead and list out those factors. Otherwise, hopefully if you get good at these, it's really fast. So we have 3. And then we have n squared and n, so the smallest exponent I see would be n to the first power. So that's going to be my GCF. That's what goes on the outside. Now we're going to look and see what's left over. So I'm going to draw my parentheses, and I should have 2 terms in the parentheses. Okay? So I'm going to take 6 divided by 3. What's going to be left over? 2. N to the second, I took out 1 n. So how many are left over? Just 1. So 2n is left over. Minus 9 divided by 3 will give you 3. And then if I take an n out of n, I don't have anything left. So that's my final answer. Remember, if you care about your grade, I would double check and see if you got it right. 3 times 2 is 6. N times n is n squared. Got it. Minus 3 times 3 is 9. N times nothing is n. So we got it. All right? I'm going to try one more with you, and you're going to try the last one on your own. So this time we have a trinomial, but it's the same process. You're going to look for that GCF. So my GCF of 25, 10, and 15, again, you can list out your factors, but this is one where I see a lot of 5s and 0s. Whenever your number ends in 5 or 0, your GCF is, or the greatest common factor, is always going to end in either 5 or 0. So I'm going to start with 5. Does 5 divide by both of them? Yes. But now I'm going to look and see if there's something higher. What about 10? Will 10 be divisible by all of these? No. So my answer, my GCF is going to be 5. Oops, I should use blue here to stay consistent. So 5 is my GCF. Now I'm going to look at my variables and exponents. What's the smallest exponent I see? They all have an x, and they all have at least one x. So 5x is going to be my GCF. Now I'm going to try and figure out what is left over from each term. So I'm going to draw my parentheses here. I'm going to have 3 different terms that are left over for this one, okay? So I'm going to divide 5 by everything. So 25 divided by 5 would be 5. I took 1x out of x to the 5th. So what's left over would be x to the 4th. Now I'm going to divide 10 by 5. I'm going to plus 2. 10 divided by 5 is 2. And I took an x out of x squared. So it's going to be x plus my third term. 15 divided by 5 would give me 3, and I'm going to take an x out of x, so I'm going to be left with nothing. Okay, last step, remember to check. 5 times 5 is 25, x times x to the 4th is x to the 5th. Perfect. 5 times 2 is 10, x times x is x squared, and then 5 times 15, I did it, sorry. 5 times 3, thank you, is 15, and then x times nothing is x. Okay, so that's why it's good to check. Sometimes you might make a mistake or think you made a mistake. Alright, so go ahead and try example number 4 completely on your own. Remember to find that GCF and then look for what's left over. Check your answer when you are finished. See ya!